Hello guys and welcome back after the ad break, and let's continue with question 2.4 showing valley climates. Now our first clue looking at this diagram, what do we notice? We see sinking air, and when sinking air takes place in valleys it's known as a katabatic breeze. Now, what else can we notice over here? We've got some industries taking place over there. There's a lot of pollution at this level. And B is known as the thermal belt. Or you can say inversion. Now, how does this basically happen? Because what happens during nighttime, the surrounding areas cools down, the cool air sinks to the bottom of the valley. What does it do? Displaces the warm air up, creating the inversion layer. Now grade 12 is very important. Let's just quickly define inversion again. An inversion is an increase of temperature with an increase of altitude. What's very important over here, it's a negative lapse rate. Now, for instance, let's say for instance I go and climb Kilimanjaro. The higher I go, what's going to happen with the temperature? It's going to decrease. But in this case with the inversion, what happens with the temperature? It's increasing, so it's a negative lapse rate. Now over here, the industries, as you can see, creates a lot of pollution, but let's quickly go and have a look at these questions that they ask in question 2.4. Name the wind labeled A. As you can see, it's a katabatic breeze, it's air sinking downslope of the valley. Very importantly as well, I'm just going to draw a little moon over here because it happens during night time. So what's the type of breeze that we experience over there? Katabatic breeze. Explain why this wind occurs at night, and the reason for that is because the upper slopes cools down that's your first reason, and another reason is because the air cools down and it moves down the slope. Moves down the slope, collecting in the bottom of the valley. A temperature inversion is formed at B. With reference to figure 2.4, assess the impact that is likely to have on the health of the people living in the area. Now, if we go back to this temperature inversion, we discussed earlier the reason why it exists because the cool air collects down the bottom of the valley. What does it do with the warm air? It displaces the warm air up, creating a temperature inversion, because what happens now, let's say the temperature down here is 1 degree Celsius, but up there the temperature will be 7 degrees Celsius. That's the reason why I'm referring to it as an abnormal lapse rate. Temperature is supposed to decrease when we go up in altitude. Now, as you can see, because of this temperature inversion, this warm air, what does it do? It traps all these pollutants, creating smog. Now, what is smog? It's a mixture of pollution and fog. Now, coming back to the question, what negative impact does it have on humans? First of all, it can cause diseases such as asthma. It can create skin irritations, and it can create unhealthy conditions for people. So a temperature inversion is formed at B. What's the health? How is it going to impact the health of people living in the valley? Like I've mentioned, it can create asthma, skin irritations because of the poisonous gas, and another reason is it can create eye irritations as well because of the smog. I'll give 2 reasons why Area C is not suitable for planting of all types of crops. Now let's just quickly have a look where Area C is. C is on the bottom of the valley. It's this area over there. Now because of all the cold air collecting down there, what's being experienced over there, we've learned that that's where the frost pocket is situated. Because of all the cold air collecting down there, we experience very cold conditions that might lead to frost, and unfortunately many plants are not frost resistant, so the farmer will lose its crop. So the correct answer is over there. Give 2 reasons why area is not suitable for planting of type of crops: because of the frost pocket situated over there, situated in the bottom of the valley, and the night temperatures drop below freezing. Okay, now very importantly, another question that you might get: if people have to settle, where will they settle? They will settle usually where the thermal belt is. Why? Because of warmer conditions, upslope, and there will be less pollution. Keep this question in mind. And obviously when we look at aspect, people will rather settle on the north-facing slopes than the south-facing slopes, because the north-facing slopes experience warmer temperatures because they're facing towards the equator and because of direct insolation. No oblique or insolation like on your south-facing slopes. That's one of the questions that you might expect during a final exam. Our next question, what do we have here? Illustrates 2 drainage basins. Now there's drainage basin X and drainage basin Y. Now let's just quickly look at some clues that this diagram actually provides us with. First of all, there's drainage basin X, and situated over there is drainage basin Y. Now what separates one drainage basin from another? It's this dot over there. Remember, that's your watershed. What's the high-lying areas that we find between the tributaries is known as your interfluve. Okay, now immediately what I pick up from this diagram, X has got many more tributaries than Y. And tributaries meaning more rivers in drainage basin A than in drainage basin X than in drainage basin Y. Now let's just quickly go and look at the questions, what they ask us over here. Define the term drainage basin. Now the correct answer for that is the total area drained by a river and its tributaries. Okay, please don't get confused between the two of them. There's a big difference between drainage density and drainage basins. Define the term drainage density, and the correct answer over there is the total length of all the streams in relation to their size of the drainage basin. Now 2.5.3, which drainage basin, X or Y, has a greater drainage density? Now let's quickly have a look at it. X or Y? Which got a greater density? Now which one's got more water, surface runoff? Definitely A, because look at all the tributaries over there. And look at the length of streams over there. Okay, so the correct answer for 2.5.3 will be X. Give one reason for your answer to question 2.5.3. As you can see, there's many streams, many tributaries joining the main river over there. There's a lot of more surface runoff over there. So what can we say is the correct answer? One sentence, many streams in the drainage basin. Discuss two factors that could result in a drainage basin having a high drainage density. Now why, if we look at this, two factors, how come drainage basin X has got a high density, much bigger density, if you look at the total amount of stream flow over there, than drainage basin Y? And the factors can be any of the following. There's the amount of vegetation. So let's say area is covered with a lot of vegetation. Is it going to promote surface runoff or groundwater runoff? So let's say, for instance, if I can compare two drainage basins there, here at the bottom of the booklet. There's diagram A. Let's just quickly have a look and discuss this. And there's drainage basin B. Now, if there's a lot of vegetation, what's going to happen? It's going to look like drainage basin B, because the water is rather going to infiltrate and promote groundwater runoff. If there's a lack of vegetation, it's going to be surface runoff. Another reason we're going to have a high density, for instance, if there's a very steep gradient, because the water won't be able to have enough time to infiltrate. If the gradient is gentle, it's going to have a low density, because the water is rather going to infiltrate. Another reason, another factor that we need to go and have a look at is the permeability of the rock. Now, when we say rock is permeable, it allows water to infiltrate. Impermeable doesn't allow water to infiltrate. So let's say one of these drainage basins got permeable rock. Which one will it be? It will be number B. We will see less surface runoff. If it's impermeable rock, it's going to be a high density. And then obviously as well, the amount of precipitation. A place in a high rainfall area is going to have a high density. A place in a low rainfall area is going to have a low density, like drainage basin B. But let's go back to the question again. Discuss two factors that could result in the drainage basin having a high drainage density, and the correct answer that we can write over there, more precipitation, and that's rainfall. You can also say saturated soils, depending on the underlying soil. For instance, if we take two soil types, for example, we take clay. Let's say, for instance, on the surface we find clay. It's very difficult for absorption of water to take place, so it's going to promote a high density drainage basin. If the soil consists more of sand, it's rather going to be infiltration. And we can say the permeability of the rock. The gradient, how steep it is. And then lastly, vegetation cover. Now, if you quickly look at 2.5.6, explain the impact of an urban development at point A, B, and C on the drainage density of the drainage basin X. So we need to focus on basin X. Now, if you look at this diagram over here, we can already see that X has got a high density. Now, imagine area A, B, and C is going to be urban settlements. Now, what factors do we bring with us when we settle down? We bring artificial surfaces to our settlement. Artificial surfaces means concrete, infrastructure, buildings, tar road surfaces. Now, do you think that these artificial surfaces promote infiltration, or we can say retard infiltration? Now keep in mind, think of it. Let's say, for instance, it's draining in a veld. What's happening with the water? It's going to infiltrate because of the vegetation. What happens when it drains in an urban area, for instance in a city? What happens? There's direct runoff. The water level rises because the water can't infiltrate. So let's look at this question. Just stay tuned after the break and let's quickly answer this question.